Well, my name is Saeed Jahanmir, and I have the pleasure of having been nominated to be the next president of ASME. I've had the honor of serving Congressman Tim Ryan from Ohio for the past 2 years as ASME Congressional Fellow. Yes, my pleasure to welcome you today to our briefing on manufacturing engineering education. And this is sponsored by ASME and is convened in conjunction with the House and the Senate Manufacturing Caucus. I want to thank you all for joining us today. And I can see by the turnout, this is an important topic. And we have many people both here in Congress and in the Washington area that have an interest in this topic. First, let me tell you just a few things about ASME. ASME's mission is to provide standards and technical solutions to improve safety and quality of life worldwide. And ASME Washington office convenes these briefings that you see today to provide policymakers with information from subject matter experts in various technical areas, including advanced manufacturing, to highlight the importance of technical developments to the U.S. economy and workforce. Today, you will hear from leaders in the field about the importance of education and workforce development. How's this? Workforce development, especially with respect to manufacturing and economic development. Let me start with just some background information. I'm sure you know what I'm going to say. The 2017 NDAA, the National Defense Authorization Act, established the Manufacturing Engineering Education Grant at the DoD. Basically, it authorized the Defense Department to support industry-relevant, manufacturing-focused engineering training. And this grant program will not only strengthen the U.S. military's capability and our national security, but will also allow U.S. to compete economically against other nations. A total of $10 million was appropriated for FY17, and the appropriation process for FY18 is still ongoing, so we see what happens there. Today's presentations are focused on this new DoD program. And I'd like to add a disclaimer. It is important to note that the presentations you'll hear today represent the views of the presenters, and they are not necessarily the position of ASME. The idea behind this program, grant program, has been strongly supported by many members of Congress, including Senators Lindsey Graham, Jerry Moran, Debbie Stabenow, and Chris Coons, and Representatives Tim Ryan and Tom Reed, and many, many others. Although they all expressed their support and intent to be with us today, with all the various events and votes going on right now on both sides of the Hill, they send their regrets. But some members might show up during our program, and if they do, we will ask them if they would like to make a few remarks, and we will interrupt the program. Well, with that, it is with great pleasure that I introduce today's moderator, a good friend and a colleague, Professor Tom Kerfess from Georgia Tech. Tom is serving as the chair of the ASME Manufacturing Policy Task Force and has served as the assistant director at OSTP for manufacturing. And Tom, thank you very much for coming all the way from Georgia. It's a pleasure to have you.
All right. Thanks, Saeed. Well, thank you, Saeed. Good afternoon. As Saeed said, I'm Tom Kerfess, and I chair the ASME Manufacturing Public Policy Task Force. My background, actually, is I grew up in a small business in the Midwest, in a machine shop, and then from there, did all of my studies and so forth. I spent a good time in industry, good time in academia, all the way from Silicon Valley startups to large automotive manufacturing operations, some time, as Saeed mentioned, over the White House. And I can tell you, in my opinion, sort of in the past 40 years that I've been in manufacturing, this is about the most exciting time for manufacturing. And I want to begin today really by giving a little bit of history or brief overview of the program that we're going to be discussing. It's the Manufacturing Engineering Education Grant Program, and it was based off, as he just mentioned, prior legislation introduced as the Manufacturing Universities Act. The program, in its current form, allows for eligible entities, including industry, not-for-profit institutions, institutions of higher education, or consortia of such, to receive grants through the program to strengthen their engineering programs and prepare students to meet the demands of modern manufacturing industry. Such programs can include curriculum development, fostering interactions between students and industry, job placement activities, and establishing joint manufacturing program with defense laboratories, among others. This program was just signed into law this past December as part of the 2017 National Defense Authorization Act. The program is housed in the Department of Defense, and we're lucky enough to have the program director for manufacturing and industrial-based policy at the Department of Defense here with us today. So we're going to be hearing about that just coming up. Manufacturing Engineering Education Grant received its initial funding in FY 2017 Defense Appropriations Package, and the Department of Defense has already begun to shape the program. But today, we're here not only to hear from the Department of Defense on how they plan to implement the program, but also to hear from experts on how their companies and institutions expect this program to fill a very important gap that's missing in today's manufacturing ecosystem. So this new program has great potential to strengthen our national economic security by working to bridge the skills gap that you hear about so often in our society as we continue to advance and innovate into the 21st century. So what this is really talking about is, if you think about it, right, our workforce is now, if I take a look at my Social Security, information that comes in every quarter and so forth, you're the workforce for about 50 years. So I'm coming out of automotive sector. Think about the car 50 years ago and how much it has changed. And think about where most of that change has been occurring most recently and how rapid that change is accelerating. So the technology is changing. And that basically means our workforce base is changing as well. We're going to hear about the education, the development, the training of our next generation workforce. But I also want to remind you that this is not only about the next generation workforce, but it is about the current generation workforce. We're going to hear, of course, from some of our colleagues from universities about lifelong learning. This is a culture that we've been promoting at universities for several decades now, and this is something that's starting to proliferate out. But this is about lifelong learning for our entire population. We see this across the board in countries like Germany and Japan, manufacturing leaders. China is certainly moving in this direction. So this is a very timely opportunity for us in terms of moving things forward. With that, what we're going to do is we're going to have every one of our speakers just give a little bit of a briefing to us in terms of their thoughts on the topic, as Saeed has already mentioned, and then we'll have some question and answers at the end. So with that, I'd like to continue our presentations. And again, please hold all your questions until all the speakers have concluded their remarks. Our first guest is Brennan Gringen. She's Program Director for the Deputy Assistant Secretary of Defense for Manufacturing and Industrial-Based Policy at the Department of Defense. Ms. Gringen coordinates efforts among the 14 Manufacturing USA Institutes. So these are also formerly known as the National Network for Manufacturing and Innovation, but they have rebranded to Manufacturing USA at the Department of Defense and other agencies to create a holistic strategy for education and workforce development in manufacturing. By the way, everybody's got a tremendous CV. I think everybody's got the little package. I'm not going to read through that because we don't have time to list everybody's tremendous accomplishments. So what I'll do is just give a brief introduction to each individual, and then we will let them talk. So, Brendan, would you like to step up? Or you can talk from your seat. That's fine, too.
Stand up.
Stand up. Why don't you come?
Oh, you want to introduce Congresswoman?
Oh, I'm sorry. So, Congressman McGovern, you slipped in there. I didn't even see you come in here. So, actually, we have Congressman McGovern from Massachusetts, who's just showed up here to hear what's going on and to express his support. Would you like to say a couple of words?
I support the program, and I don't want to take up any more time. I want to get to the panelists. I'm happy to be here with Laurie Leshin from WPI. So.
Outstanding. Well, that's, I got to say, boy, there's a congressman who just sort of gives us a straight shot there. So support the program. I'm repeating this for the camera, right? Support the program, 100%. Good. Well, thank you very much, Congressman. We really appreciate you showing up here. All right.
So are these working? Yeah. Oh, excellent. Cool. Okay. So I'm Brennan Grignon. Tom, thank you for the very nice introduction, and say thank you. I'm not sure where he went for inviting me. So I work at the Department of Defense. I work in the Office of Manufacturing and Industrial Base Policy, which sits within the Undersecretary of Defense for Acquisition, Technology, and Logistics. So I'm in OSD, under the USD for AT&L, in the DASD, MIBP, ABCD, EFG. That's how we do it at the Pentagon, and we love our acronyms. So what I wanted to talk about today is just to clarify some things about the program and what we are doing, and really help provide some guidance, I think, on what the program is and what the program is not, because I think that there's some confusion between what the proposed legislation was originally and what the actual passed legislation was and how we are utilizing it. So what the program, I'll just start with what the program is not. It is not, the original legislation did have language in it that referenced the Department of Defense's ability to grant universities a certification as a manufacturing center of excellence or something to that effect. That is not what the current legislation says. And we, the Department of Defense, are not the Department of Education. We don't do that. That's not our business. There's an entire agency that does a very good job of that. So that is not what the program is. What the program is that it's looking at where there are opportunities to do training and to build a pipeline and for manufacturing skills within this nation. And that doesn't just mean building your pipeline from the K to 12, which is very, very important, and I think we all agree. But if you have a shop floor and you've just bought a 3D printer and you're using additive manufacturing because you have a new technology need to serve your customers, you don't really have time for that kindergartner who's really great at CAD to become 21 or 18 even and work on your shop floor. So how do we all in addition to building the pipeline, how do we also train and build the re-skilled workforce that we need for the technology of today? So we're looking at that from a holistic perspective. So we look at it from a K to gray perspective is the way we describe it. So the kindergartners all the way to the guy who's been working a milling machine for 20 years and needs to understand why cybersecurity is now a core competency in his performance evaluation, because all the machines on the shop floor are plugged into the cloud. He doesn't need to be a computer scientist or know how to code, but he does need to understand cybersecurity protocols and hygiene. Manufacturing is one of the most highly hacked industries, and that is where a lot of our intellectual property is very, very critical to our national security. So that is what we are attempting to do, and the way we're attempting to do it is through the Manufacturing USA Institutes. As Tom mentioned, those were formerly known as the NNMIs and or the MMIs, and again, we go into alphabet soup, but just know that they are Manufacturing USA. There are 14 of them. There were 6 as of August 2016. There are 14 as of January 13th, 2017. So more than half of them are brand spanking new. So they're still trying to figure out where they are. They're in 14 different technology areas. The Department of Defense supports 8. Department of Energy supports 5. And Commerce has just stood up there first, which is in biopharmaceuticals. So as the lead for the majority of the institutes, DoD has taken the role, and myself personally, as coordinating the education and workforce development efforts across all of the institutes. So I work with myself. I have a counterpart at Department of Commerce and a counterpart at Department of Energy, and we all work in coordination together. One of the other things I wanted to just clarify on the legislation is that oftentimes legislation is passed with the best interest of the taxpayer and the constituents in mind. But there is sometimes a disconnect between the passing of legislation and the actual implementation of programs. So while the legislation says that there is a grant program, the program isn't actually a New Start program. So there isn't a new office within DoD that was stood up to execute this program. There isn't a new program manager. There wasn't a new program line set up to execute the funding that was coming to serve this program. So what we've done is that the funding has come through the National Defense Education Program funding line, which is in the Office of the Secretary of Defense for Research and Engineering. And if I had a whiteboard, I would draw this out because I'm getting a lot of like, what? And maybe it's just the post-sandwich, malaise. But the Office of Research and Engineering owns the National Defense Engineering Program, the National Defense Education Program funding line through which the money came. Now, the good news is that my office, which runs the Manufacturing USA Institutes, works very closely with research and engineering. They run the DoD's STEM programs, but through the Manufacturing USA Institutes, we do a lot of STEM work in the K through 12 space. So what we've done is that we're working with research and engineering to allocate some of the funding to the Manufacturing USA Institute efforts. And then research and engineering is also looking at STEM programs that are run through the department, because the STEM piece of it, the engineering piece, is that core competency within research and engineering, which is also very important to national security and is also called out in the legislative language. So I will pause and take a breath and say, does that make some sort of sense? Does everyone feel somewhat more informed? Yes. Yes, excellent. Okay. I can have a drink now. Just kidding. So one of the things that we're also trying to focus on is the recognition that this is not a new problem. The skills gap in manufacturing has been a problem in this country for a long time. It ebbs and flows oftentimes with recession periods. And we recognize that the DoD, we sometimes, and thank you, Tom, for the clarification. This is my personal opinion. I'm not speaking on behalf of the Department of Defense. While I am a Department of Defense employee, please do not tweet anything out I say and say Secretary Mattis said it, because that's not the case. We recognize that the DoD, as we ebb and flow in support of our warfighter in conflict times, we oftentimes create these situations where the skills gap happens. So when we are at war, as we have been for the past 16 years in 2 different areas, we have requirements that require specific skills, and we need to build up those requirements for capacity. Prior to the Iraq and Afghanistan conflicts, we were not engaged in that level of conflict around the world. So we didn't necessarily need the volume of tanks and planes and ships and ammunition and all of the subsequent requirements that go through that. And that is where we work with our industry partners, and Denise and I sit on a workforce roundtable together, where we work with our industry partners, because as many of you know, the DoD doesn't make a lot of things. We buy, we acquire. A lot of the systems that we actually utilize in the field, we buy from industry. So we recognize that industry's skill gap problem is a problem for us, because at the end of the day, the entire defense industrial-based ecosystem, the health of that defense industrial-based ecosystem is a national security requirement for the department. So whether you have an engineer who works in a lab at Carter Rock at one of our naval warfare centers, or it's an engineer who works on a program system at Northrop Grumman or Lockheed, or even a small manufacturer that's 2 or 3 tiers down on the supply chain, that engineer and the technicians who support them, who may just have community college degrees, which is appropriate for their job skills and adequate and actually a great way to get a good job, those are all important people to our ecosystem. So we recognize that we have that responsibility, and we're trying to utilize this program and utilize programs like the institutes and our work with industry and with OSD and their STEM program to build the entire ecosystem. So with that, I think I will just pause and hand it off to Lori.
Thank you very much. And I think this is a critical issue to point out. So we talk about manufacture, but there's also an awful lot based on sort of the production. We're making new aircraft and so forth, but we also see this. For example, I go down to Warner Robins Base, which is just south of Atlanta in the Macon area, and they're rebuilding the C-5As and the F-18s, right, to keep these aircraft in operation for the next couple of decades. And so there, it's not only on the industry side, right, but we need that training also on the Department of Defense side. And again, not only for DoD personnel, military personnel, but also civilian sector personnel working to keep our armed forces still operational, through the rest of the century and beyond. So with that, I want to thank you, Brennan. Let's move on to our next speaker, Lori Leshin, and she is in her third year of service as the president of Worcester Polytechnic Institute, also known as WPI, in Worcester, Massachusetts. She spent 6 years at NASA in several senior executive roles, including serving as the deputy director of NASA's Future Human Space Flight Program. So, please, Lori.
We'll just do this from here, yeah? Works. Let's see, is that working?
Yeah.
All right. Fantastic. Thank you, Tom. And thanks to all of you for coming out. Congressman McGovern, I'm really honored that you came here today, and thanks for supporting the Manufacturing Caucus. It's a really important part of seeing the congressional support for the kind of work that we're doing at institutions like WPI and like all the universities represented up here is very important to us. So thank you for that. So I do sit here, in fact, as a former senior leader in government and now as a college president. So kind of having that high-level view of how educational institutions can help to be a part of the solution to the challenges that we face. I have, through my government service, really seen the opportunity that is there through programs like this to really move the needle, to really change behavior. And so I want to, thank you, Brennan, and for those of you that pushed to get this program started. I think it is important when the government says, look, this is important to us, that we start thinking differently, thinking more innovatively about how it is we're addressing skills gaps now, today, and into the future. And we're willing to put our money where our mouth is and really fund those innovative programs, people who really are willing to think about things differently. So I've seen that work in other disciplines. Yes, I am a rocket scientist, but we have some of the same challenges there because, believe it or not, we build rockets in this country, and so there are a lot of manufacturing challenges there as well. So I really do believe that this program has the potential to move the needle. And I just would say, imagine for a moment that the Manufacturing USA investments, which are significant, right, are wildly successful. Imagine what if we actually achieve what it is we're trying to achieve here, right? Which is massive growth in our manufacturing sector, but in new and innovative ways. Who is going to take those jobs? Who are the workforce who are going to be prepared to really step in when we're wildly successful with this program? So really, to me, that's what manufacturing engineering education grants can be about, is helping to make sure that when we are wildly successful with these investments that we're making as a country, that we have the workforce that's prepared, not just for the jobs that are created today and in the next 5 years, but as we are seeing, those jobs are all changing incredibly rapidly. And I think this is one of the most important points, is that the landscape now, the change time of that landscape is just going to continue to accelerate. So this isn't only about how do I equip somebody with specific skills that will serve them today and in the next 2 years. This is about how do I build a workforce that are agile learners who are thinking not of going to school and then working, but who are thinking about working and learning together for their whole lives. So this is a very different way of thinking. It's lifelong learning is kind of the buzzword, but I think it's working and learning and working for one's whole career. So just to say a little bit more about the challenge and the opportunity ahead. So just a couple of statistics. So we graduate 1.9 million bachelor's degrees a year in this country. Only 100,000 of those are engineers of the 1.9 million. So if we really want to compete in the global innovation economy, that's not nearly enough. So there could be an argument to be made, we need to just dramatically turn up the numbers here. But I guess what I would say is numbers are good, they're necessary, but they're not sufficient. So this isn't only about kind of more engineers and training people in certain skills. This is also about how we are educating people, how they are thinking about their education throughout their career, and what approach we are using to make sure that these folks are well prepared for this world they're walking into. And if you just think about where we're headed in manufacturing, 3D printing, advanced composites, human-robot interfaces on different levels than we've ever seen, Internet of Things embedded in everything we're manufacturing, the sensors and all the data that's coming out. It's a very different world of manufacturing than we saw even a few years ago, and we're seeing that through Manufacturing USA. But more importantly, again, it is changing very fast. I'll just do a very, very quick aside, and I won't give specifics on this, but one of my trustees is the head of commercial aircraft engines for GE. And he's told me the story just very recently about they had put 30 engineers in a room and said, look, think very differently about how we manufacture some engine. And I don't have the numbers on this right, so please don't tweet these numbers because I won't get it right. And they didn't say, reduce from this many parts to that many parts, or you're constrained in this way. They just said, use modern manufacturing techniques, use additive, and go in there and redesign how we make this engine. And at the other side of that, a month later, they came out and they took an engine that, and again, this is where I won't get the numbers right, used to have 350 individual manufactured parts. It will in the future have, I think, 6. This is the kind of dramatic change that we're talking about in manufacturing. Very, very different. So it's not just how we make things that's different. It's how we design things. It's how we think about end of life, end of usable life for these things that we're manufacturing. It's all incredibly different. So we need, again, to create these agile learners. So the way we think about this at WPI is to think about much more real-world experience for our students. Connected, real-world, industry-driven, hands-on learning, and across the career arc. So at WPI, and again, I don't want to get into too much of an advertisement here, but we're really passionate about project-based learning as an approach to training not just a few people to do certain kinds of manufacturing, but training all of our students. And yes, by the way, before I talk about that, yes, we do create responsive programs to industry and robotics engineering programs that are massively interdisciplinary, or we start biomanufacturing education and training center to take people trained in traditional manufacturing and equip them with skills to do biomanufacturing. We're working with AIM Photonics to build out a training center at WPI right now through Manufacturing USA. We do all those sort of topical and specific things, but to me, the real opportunity here is to fundamentally shift not just the way certain students who go through those programs are trained, but the way all students are taught STEM skills, and do that in a much more holistic, hands-on way. So 100% of students from WPI graduate with multiple intensive project-based experiences that are based in the real world. We have 46 project centers all over the world where our students and faculty go and work with local communities, local municipalities, local companies to solve real-world problems. So they come out with multiple experiences having done that. And we do that at scale. 100% of our 5,000 students have those experiences. And I think that kind of innovative approach where we're really willing to take the chance of doing something dramatically differently in our education programs are the kinds of things that new grant programs like this could really encourage and try to foster. And just to close out, just to say, does this really work, this project-based approach to learning? So we've actually now we've been doing this for a while. We've really scaled up the off-campus embedded in the world portion of it recently. We have a lot of data now from students who have experienced that from surveys that we do of our alumni. And we ask them sort of, how does this impact you? What are the skills that you think you've gained from going through a program like this? And the number one thing that the students themselves say that they get from going through a hands-on project-based approach to learning is they take responsibility for their own learning. They say that's the number one thing they get out of it. So as you talk about creating people who are lifelong learners, who understand that I'm going to have to myself figure out in this changing world how to manage my own learning and education, this project-based intensive hands-on approach we think is a really good one to focus on, partnered with industry and again all along the pipeline. So again, I think this grant program is a huge opportunity. It's a great promise to address a national need and really increase the prosperity for families around our country if we can do this right, and that's a huge opportunity for all of us. So I think the key to success will be focusing on universities that are willing to be true innovators, that are willing to think differently and work differently and partner differently. And thanks again for having me. I look forward to the discussion.
I want to make sure everybody knows I broke my no tie rule for you people. So, when we grow up in manufacturing, right, you can't wear ties because they get caught in the equipment. This is a very important topic for me, and it's the reason it's important is, as Tom mentioned, I've spent some time in industry. I've spent 10 years in industry. Though I'm speaking to you from an academic perspective, this I've seen and I've touched it and I've felt the problems that we have in industry, and it motivated me to. I am a lifelong learner, right? So I think a lot of us in academia are, and it motivated me to come forward, and so it motivated me to come forward and try and solve a lot of the problems that I ran into. I came to Clemson 10 years ago in order to help establish a new program in automotive engineering. So this was a disruptive way of looking at how we can rethink education around an industry. So we took the automotive industry and we built a program that would serve from a research standpoint and serve from a graduate student standpoint by working together with them. So we went and we talked to the BMWs and we talked to some major suppliers to the automotive industry, and we said, you get these students out of traditional mechanical engineering programs, and then you set them down and you train them for a year and a half. What are you training them in? And so we talked about some of those soft skills, some of the teamwork skills, some of the real hands-on, this project-based learning, this open-endedness, and that became our curriculum, and it's been wildly successful. We're working now to take the graduate level engineers and back that up to the undergraduate level engineers and back that up to the technical colleges as well. We're working on certificate programs with manufacturing, certificate programs in automotive engineering, and we're serving the automotive industry now. It comes at a price, and so that's the message that I would like to bring, is that I support investment in the manufacturing engineering education program because it's not an easy task. It's wonderful to look back on, right? 10 years, we can look back on our success, we can look back at our industrial partnerships, but this took $250 million of investment, and that was investment from the state of South Carolina, that was investment from our industry partners, and investment from the university in order to realize this. We've got a wonderful faculty now, and the faculty are not just mechanical engineers. They're mechanical engineers, electrical engineers, psychologists, business people, and we're teaching these students about systems integration and the integration of systems and how you can be a technical specialist, but you need to understand the impact of your decisions on other areas. That's other organizational areas and other technical areas. Give this a shot. So in our working with industry, this is the key, I think, to the success of this program. You're not just holding a workshop, finding out what industry needs, and then going and creating a new education program. This has to be a disruptive change, and you have to be together, integrated with your industrial partners. So we've got research, of course. Our research portfolio, whereas a traditional program might be 10% industry funded, we're 80% industry funded. And we're providing knowledge results in terms of research, but we're also providing engineering results that are paying off for the companies. So this has to be financially motivated for the company. In fact, with the end of each research project, we're doing a return on investment calculation. So they invested in this research, and we're showing them improvements in quality, productivity, and personnel development. The students that come out of the program are surprising in a good way. So they're surprising to the companies that hire them. Companies in the automotive industry are coming back to us and saying, you got a student that does all the mathematics, does all the predictive modeling, but can also get down in the lab and set up the data collection system in order to validate their models. What kind of engine made this student? And we have companies that fly down, visit us, start research programs with us, and it has been going on for years and years. And this is not just a one-time thing. This is companies that have been returning to us. In fact, now with BMW, we're working very closely on building the nation's first pilot plant for manufacturing. And this is where I really want to get at the project-based learning. So when you do a project and you go into a plant, you want to have the plant experience, and they're like, yeah, we can give you 5 minutes at 3 o'clock in the morning. you're not going to learn anything there. So we're building our own factory. It would be a full vehicle assembly factory with parts and with logistics. And now we can push the students in areas where they're going to fail. It's wonderful. I love to see students fail. We can stop the machine and we can say, what went wrong? Let's take this as a learning opportunity. So we're not just doing projects and executing them, but we're actually stepping back and sort of becoming Socratic about it and having the students feedback to us. This, I think, encourages this lifelong learning, this agile learning where, oh, if I can apply that and, learn something about robotics, I can apply that and learn something about whatever the next technology is that's coming up. So, bragging on Clemson a lot, but what does this mean for the manufacturing engineering education program? We have a skills gap that is undeniable. In my role, I get to talk to industry leaders every day. And I am making presentations about my research. I'm very proud of the work that we're doing. And the answer is invariably, that sounds really interesting. How many students are you putting out and when can I have them? This is the response. Not to be rude, but we don't care about your research. We care about your students. And so this was really a big awakening for me about 5 years ago when we started envisioning this pilot factory. This factory is not about research. This factory is about education. It's about putting students in situations where these open-ended problems and they have to go figure out what's going on. Dr. Mears, you didn't give us enough information to solve the problem. Yes, now welcome to the real world. That's what's going to happen. And so that's the way that I think we can push people to learn for themselves. So the point with the manufacturing engineering program is we have this type of model, and this is a model that can be scaled. It can be replicated in other industries beyond ground vehicles, all the way across DoD. And we can really start to realize the power of the network. Now we can start to share best practices. We can start to share resources. We can have common instruction, right? I teach a course in machining modeling, right? Is mine the best or is somebody else's the best? And we can share that around the network. This becomes very powerful beyond what individual universities can do. So we've talked about the NNMIs, or the Manufacturing USA Institutes. These are institutes of innovation. The manufacturing engineering education program should be institutes of education along the same model where we can start to share our best practices. We're developing new ways to educate people, not the new technologies that they're going to learn about. Those are coming, right? That's where the NNMIs play, but about new ways to educate people on how to be relevant in those technologies. I have a dream, right? I want to see my technical college students that are working in this pilot factory graduating, going out to a company, having somebody say, here's our new machine, let me show you how it works. No, let me show you how it works because I work together with the research students that helped develop the process in the first place. So we see that we're on the right track. And it's this kind of step change in the way we educate students that's gonna make all the difference. So I encourage everybody here that has the power, support this MEE program. This is a key building block of the nation's economy. This is something that helps us maintain our competitiveness. And sorry to say it, we are way behind. We're way behind other countries, and I hear it every day in my discussions with industry. So it's very important to support. That's my message. Thanks.
Thank you, Lane. So very good. And again, the thing I really want to point out is if you go over to the South Carolina area, to the Greer area where the BMW plant is, you will go to the high schools and you will see the high school students who will say, I want to go into manufacturing. I want to go into automotive manufacturing. So they are excited about it, right? How do we leverage that excitement? How do we get it out to the rest of the nation? By the way, it's not just there in BMW. You go to Charleston, right, where Boeing is building 787 aircraft. It's the same type of thing. We have a good, again, foundation. You heard about 3D printing, right? And so we heard about 3D printing, and that basically took, I think you have some of my notes, Lane. So that I'm going to have a hard time introducing our next speaker. Yeah, thank you. So, but basically, they're makers, right? What we need is manufacturers. It's great to print out a little plastic trinket, right? They're excited about it in the whole bit, but next step is how do you go from that plastic trinket, right, to that nut or to that ball bearing or to that circuit board, right? And a lot of that is starting to come together, and we see it, in terms of the students that are starting to show up at our doorstep. So it's an exciting time. Anyways, so let me move on to our next speaker, Stephen Ezel. He is the Vice President for Global Innovation Policy at ITIF, the Information Technology and Innovation Foundation, which is an influential think tank here in D.C. He focuses on science and technology policy, international competitiveness, trade, manufacturing, and service issues, and has co-authored papers that focus on innovation economics. Stephen.
Well, thanks, Tom, and to ASME for inviting me to be here today. So in 2013, ITIF and the Information Technology and Innovation Foundation and Brookings co-wrote a report called Creating the Manufacturing University, which called for the federal government to support the designation of approximately 20 manufacturing universities supported by a federal investment of $20 million per year to help these universities revamp their education, their engineering education programs with new curriculum and with a focus on skills that are needed by America's advanced manufacturers. That proposal eventually got turned into the bipartisan manufacturing universities legislation proposed in 2016 by Senators Coons, Ayotte, Graham, and Gillibrand, language from which was ultimately incorporated into the 2017 NDAA as the Manufacturing Engineering Education Grants Program. So I'd like to take a few minutes to talk about why we believe this program is important and what inspired us to make the proposal for manufacturing universities in the first place. And first, there are four reasons. First, we felt that at too many universities in the United States, a focus on engineering as a science increasingly moved university engineering education away from a focus on real-world problem solving toward more abstract engineering science. And so there was a need, as Lori talked about at WPI, for mechanisms to incent and encourage universities to introduce more joint industry university research projects, more student training that incorporates real-world manufacturing experiences, greater PhD engineering graduates working in industry, and more community outreach, building on programs like what Georgia Tech does, which has appointed a chief manufacturing officer to oversee universities' interdisciplinary manufacturing programs, as well as ascertain how they can maximize impact on regional and local economic development. And we think this is important for three key reasons. First, because as Lane talked about, there truly is a manufacturing skills gap in the United States. If you look at the latest Deloitte Manufacturing Institute skills study, they report that 84% of U.S. manufacturing executives see a talent shortage. That's up from 67% in the 2013 study. And it further contends that as many as 2 million of the 3.5 million manufacturing jobs the U.S. economy will create through 2025 may go unfulfilled because of this skills shortage. Elsewhere, Accenture finds that fully 80% of the current U.S. manufacturing workforce is unprepared to fully take advantage of the smart manufacturing or ICT-enabled manufacturing revolution because they simply lack the skills that will be in demand. Another reason why we felt it was important that America imagine new approaches to engineering education is because it would help bring us more in line with the successful practices of competitors such as Germany, a country for which manufacturing contributes almost twice as much to GDP as it does in the United States. In fact, if you roll the tape back to the year 1987 and adjust for changes in working age population, Germany since 1987 has lost just 8% of its manufacturing workforce. We've lost 43% of our workforce. And a core part of Germany's strength in manufacturing is that industry-university cooperation is institutionalized through programs such as Germany's network of 70 Fraunhofer Institutes, which focus on industrially relevant R&D activity, with industries and universities working hand in hand to identify technical challenges faced by industry, to fund research and training at universities, so that when engineering graduates come out, they're not equipped just with industry-relevant skills, but they also have specific technical knowledge and competence to drive Germany's industrial capacity forward. But finally, and the most important reason why we think we need greater engineering focus in the US, is that America has long clearly led the world in science-based innovation. and that's vitally important. But science generates knowledge that is essentially a non-rival, non-appropriable public good that can quickly be picked up, leveraged, and copied by foreign competitors. And that's why science-based discoveries aren't enough for the US anymore. We also have to be able to make things here. And that requires engineering-based innovation, turning abstract ideas into viable products. And this is an appropriable activity through which US-based establishments can add and capture value. Put simply, America has to get better at turning science into US-made high-technology products, and engineering is the vital key link in this chain. Yet still, the federal government has traditionally only invested a small fraction in engineering development, perhaps just 1/7 the amount we invest in basic scientific research. So in conclusion, a grants program that provides Kickstarter funding to catalyze and encourage experimentation with innovative new approaches to manufacturing, engineering, and education can play an important role in bolstering America's engineering competencies, and this can contribute to manufacturing competitiveness, economic growth, and national security. Let me just say that our talent gap in manufacturing is a critical concern, not just for America's industrial competitiveness, but also for the readiness of its defense industrial base, as Denise will talk about, as well as the military preparedness. When we look at successful programs like WPI or the Olin College of Engineering in Massachusetts, they've used new thinking towards engineering education to wonderful ends. If you look at Olin College there in Massachusetts, they've completely reimagined university engineering education. It's all project-based. There's no faculty for the tenure. Half the students are women or minorities, and their graduates are producing as many new startups per student as MIT. So it's time that we got more creative in America about thinking of new approaches to engineering education, and we support the DoD's efforts to lead us in this path. Thank you.
Good. Thank you very much, Stephen. So, I mean, I think that this is some very critical statements there, and in particular, I mean, one of the things, and I do see it changing, at least in the academic environments, letting engineers do engineering, right? As opposed to just saying, well, we're going to focus on science and sort of the fundamentals, but building things, right? I mean, we've just heard building things, hands-on, problem-based learning. This is what's going on. This is what put people like Neil Armstrong on the moon, this can-do attitude. I was lucky enough, I did my graduate work at Draper Labs, and I worked with people who were on those programs, who could make things move forward. When Lovell and his crew on Apollo 13, right, lost the service module, right? It wasn't, oh, gee, I don't know what to do, and there was no Google. I already pointed that out. They solved the problem. These were engineers and scientists, and they moved it forward. They brought it to reality overnight. And it was amazing, right? And we see that still today. I tell you, we still have tremendous opportunities today, and what the engineering, what the manufacturing is going to allow us to do is enabling that innovation. Great ideas, right? I think, if you've started up a company, you've heard about this, well, you have to have a great business plan, before you even think about your idea, right? But if you can't bring your idea to fruition, not going to make a difference. You're not going to make the money. If you want to think about it from a more altruistic perspective, and our students are thinking less about making a profit, about making a difference in the world, if you can't scale it up, you can't make a difference. Think about the Salk polio vaccine. If we couldn't have made billions of copies of that cost effectively and accurately, we could not have eradicated something like polio, right? So it is making a difference in terms of manufacturing, biomanufacturing in that area. So our final speaker today is Denise Peppard, and she is the Corporate Vice President and Chief Human Resources Officer for Northrop Grumman Corporation, which is a leader in global security. Her responsibilities include talent development and acquisition, executive development and training. She is also a member of the company's Corporate Policy Council. And I think that this is an appropriate person as our final speaker to really talk about what our workforce looks like, what our needs are looking like, and how we're going to meet them. Denise, please.
Thank you very, very much. Good afternoon, everyone. I hope you know us at Northrop Grumman. We are a company of about 67,000 employees. We do hire an awful lot of engineers. As a matter of fact, we're well over 4,000 hires already this year and headed for 7,000 by the end of the year. So it is a great topic, workforce, and the gaps that we see. Northrop is very excited about the establishment of the Manufacturing Engineering Education Grant Program. But there are aspects that I won't repeat, I hope are still in the legislation. I didn't realize it had been tweaked, but it's really important to us as well that the expansion of the manufacturing training and education pertains to the members of the armed forces and our veterans. We think this is critical. We hire about 30% of our hires are veterans, and this is a critical source of talent. And we need to help provide the right training so that they can find good jobs. And there are a lot of good jobs out there right now. We also particularly appreciate in the legislation the focus in the grant award selection criteria on achieving high levels of participation of women, minorities, and people with disabilities. There's just simply a paucity of talent, of diverse talent in the engineering fields. It's a shame that we aren't attracting more young girls and minorities into these STEM engineering fields. And we believe it's a critical part of our talent strategy, and so we love that part of the legislation. You know us as an A&D company, aerospace and defense company. We are also a company that is a member of the Business Roundtable, which is a consortium of many large companies, CEOs participate there. And we were all feeling the talent shortages in the engineering fields. And so in 2016, the BRT conducted a talent survey with other BRT members, which crosses many different industries outside of A&D and with A&D as well. And what it confirmed is that we are all struggling to find the talent with the appropriate technical skills to fill the jobs today, as well as to have the learning capacity to fill the jobs of tomorrow. And as you've all heard mentioned here with the other panelists, the technology and companies keep changing, so that agile learner is really an important attribute as well. We really see the value in this new grant program as encouraging increased investment in manufacturing technology and development programs, both enhancing the ones that we have and building out the new ones that we need to have. We need increased focus and investment on curriculum and faculty development. We cannot forget the faculty needs to come along as well and as swiftly to modify existing and to build new manufacturing and technical education programs that will be helpful to industry, because it will help us to leverage and to scale our investments. We are making significant investments in partnering with higher education to shape new curriculum and also to help on faculty development where there are new technologies. We work closely with our higher ed partners because higher ed institutions need to understand that the industry's future workforce strategies, they can't do that without great partnerships and areas of technology innovation that we in industry are moving towards. But industry is limited to making investments that help workforces in their locations. But there is huge potential when there are government grant programs and government support to scale the best practices and to leverage the partnerships that each company is individually pursuing. I'll tell you about just a couple of such partnerships and why there is so much potential. We have one with the Antelope Valley Community College in Palmdale, California. Together, Northrop Grumman and Antelope Valley Community College created a new curriculum that we needed more talent in to create an aircraft fabrication certification program. It had content like basic blueprint interpretation, aircraft structures, composite fabrication, and repair. This partnership is a true win-win for the community to develop qualified candidates for entry-level manufacturing positions. The credits for the 2-semester program result in a certification, but all the credits can be applied to a bachelor's degree program, airframe manufacturing technology. We hire about 90 to 95% of the graduates. We'd rather not give them to a competitor that might be nearby that location. We've already hired 1,000 since we started this partnership. We'll hire 2,000 to 3,000 more. It's critically important that we continue to help, to partner with institutions to shape the curriculum. Let me tell you about another one. University of Maryland, College Park. With University of Maryland, College Park, we created the Advanced Cybersecurity Experience for Students, and you are so right, in almost every job, there is a need. And we were not getting enough graduates in the cybersecurity area, but also we were not getting diverse students. And so one of the things that we liked about what the University of Maryland College Park program, and by the way, we have a similar arrangement with Baltimore County as well, is they source and attract from the high schools diverse candidates, and they provide 2-year living learning undergraduate program and 2-year minor in cybersecurity. It's critically important. We don't have it branded Northrop Grumman. It's to build the pipeline of talent that we need in this nation right now. We've invested. It's time consuming. It took us almost 3 years to get it up to speed. But, we have 250 students enrolled in that program right now at the various levels, freshman, sophomore, junior. 250 is not enough. What these kinds of programs will help us to do will be to leverage and scale when we have a best practice model. Across many universities and companies, retail needs cybersecurity people. Every time there's a financial breach, I have a hard time finding cybersecurity people because that's where they go next. So, we really need to scale and leverage. We need 250 times 100 to fill all the need across the country. So think of the possibilities if this approach was quickly scaled to other community colleges or 4-year institutions in other states. To take the model with new curriculum and methods to other schools saves time and gets the programs to students more quickly. So industry views the opportunity with the grant awards as encouraging, especially the opportunity to create grants for consortia of companies and universities. I think it ought to be a true focus to expand the partnering opportunities. As I read the legislation a few times, I would only have one maybe caution to share with you, and maybe it's by design that legislation is written oh so very broadly to include a lot of things. I think the most important thing that I worry about is we need to focus on where the talent shortages are, where the supply problem is. Implementation is going to be critically important because we can't do everything with $10 million. Our investment at university, our initial investment at University of Maryland College Park was $3.5 million. So we need to make sure we're getting it to the right places where we have shortage of talent in many engineering field areas, and we need to measure outcomes. That's what we have to do when we are making those investments in industry, and that's what I would hope for this grant program as well. The other thing that I think is critically important about this focus on education, the lifelong learner must be a faddish concept, but it's actually real and important to industry because technology does change. And we don't want to lay off people. We want people to grow with us. We want people to stay with us. So we really want to help people to learn the skills to take a job and learn the skills that they are transferable as technology changes so that they have a career with us and not just fill an immediate today's need. That's what we're looking for. That's what's going to protect our economy, and that's what protects the individual as well. So those are my thoughts. Thank you.
Great. Thank you very much. I just, I want to point out, right, I mean, just in terms of the whole conversation about diversity and so forth and engagement across the board, I mean, half of our population is female, right? And so, I mean, if you don't engage it, you've already lost 50% of your workforce, opportunity. I mean, just some simple numbers there, right? And I can tell you, we see them, at Georgia Tech. Well, I can tell you, my daughter's a mechanical engineer. My wife's a mechanical engineer. In fact, you're probably more apt to see them changing the oil than I am on the car on any particular day. It is a different world out there, and we really do see them engaging. I mean, it is just amazing to see them. I've been teaching for, I guess it's closing on 30 years now, and it's a very different mindset and so forth, which is good. We are moving in the right direction, but we have a lot further to go. But again, it's just a matter of simple logistics. We need people in those positions, and we have just got to engage. Well, thank you very much, everybody, for your excellent presentations. And what I'd like to do now is turn to our guests out here, invited guests. Samantha's got the microphone. And if you have some questions, we've got about 20 minutes or so. We'll end right on time because I know people have very tight schedules here. But if you wouldn't mind, please state your name and organization before asking a question. And again, I would ask you to ask a question, so a question as opposed to just a remark, and I may repeat it just so that we can get it also on the camera over there as well. Please.
Hi, yes, Angela Anderson, University of Delaware. Question for Brennan. Can you go into a little bit when you're talking about the funding? Is that going to be specifically only for Manufacturing USA, or will others be able to apply for it as well?
I think it's on now. Yes. I'm not a mechanical engineer. I'm a biologist by trade. The funding is not only for Manufacturing USA. Actually, the majority of the funding is not even for Manufacturing USA. So as I explained earlier, and I know it got really complicated, so we're actually working with research and engineering on a white paper or something to explain all of this. Research and engineering, the Office of the Assistant, they're currently still an Assistant Secretary of Defense for Research and Engineering, runs the National Defense Education Program funding line. That is where the money was placed. So they have determined that most of the money would be utilized for STEM-oriented education and or open BAAs, and then there would be some of the money that would be allocated that we could utilize through the Manufacturing USA Institutes. So that's where we're at right now. Part of this, I will say, and again, this is my personal opinion, so don't hold this against Research and Engineering or the Secretary of Defense or Congress or anybody else. Part of the challenge that we see is that this program legislation language was signed in December. The funding came 2 weeks ago. The end of the fiscal year is in 75 days. And again, the legislation didn't actually start a new program. It just said you would do this under existing programs that we already have. So there was, I think, a little bit of a disconnect, and I think that it's done a disservice to a lot of people in the community that are doing this good work to figure out, okay, I heard this $10 million got allocated by Congress. What are you, the DoD, doing with it? And we don't have a really clean way of just going out to the universe and saying, what are your great ideas? Now, I think we're recognizing that. We recognized it previously. And so if there is funding that is associated with the program next year, there would be, I think, more of an impetus for us to say, okay, but can we think about where that funding goes from a program funding line perspective, and then who has the authority to allocate the funding and to whom is that money allocated? We utilize the Manufacturing USA Institutes because from MIBP's perspective, those are consortiums. They're public-private partnerships with industry, government, and academia members. So to us, that was in such a short period of time, a way to reach the largest audience that we possibly could, given the mechanisms that we currently have in place. That was a really long answer, but it's complicated.
But it makes sense. I think it's on target. Thank you. Good. Another question. Yes, up here in the front.
Hi, my name is Edith Alston.
We'll get you the microphone.
Oh, okay, thank you. Okay, hi, my name is Edith Alston. I'm representing the Institute for Improvement of Technology. And I wanted to put the question to Ms. Pepper, who I was very impressed with, the fact that that program that you spoke of at the University of Maryland, my niece went through that program, and she has a very nice job with the Department of Navy.
Nice.
And the fact that there are several programs that I've noticed through the University of Maryland that quite a few of our students at our church has participated as a diversity and minority students, has implemented them in a very nice way, and they have gotten very good jobs. So my compliments to you.
Thank you.
Nope. Very good.
Can I just say one other thing on this
Please.
topic? I don't know, the light go on? It's on, yay.
Leave it to the biologist.
So
Yeah.
NSF has also done some really nice programs with investing in cybersecurity at universities around the country. We've had some funding from them too. My bet is University of Maryland's in on that as well. So again, it's another great example of showing how some little bit of federal incentive can actually really help us help you build the pipeline, right? So for us, we have, you can basically go to WPI for free if you want to study cybersecurity. And that's because, again, of great collaboration between the, federal funding and the institutions. So you can move the needle with these sorts of investments. And I think it's great to hear about your niece. That's fantastic. You must be really proud.
Outstanding. Good. Other question? Yes.
Good afternoon. My name is Peter Dorhout. I'm with Kansas State University. I want to thank you all for being here this afternoon as well. Thank you for mentioning veterans and engaging our veterans in this kind of a program. I do want to ask a question, however, and that's how does industry embrace where this is headed? And in particular, I'm a product of the co-op programs that were back in the 70s and 80s, very popular, and that's kind of waxed and waned over the years. And where does industry, and particularly in partnership with the DoD, stand on revitalizing, re-energizing? I know that having a corporate partner in these programs is very critical, and I appreciate what's happening with ICARS and the programs that are there associated there. So industry-wide, how are we thinking about revitalizing the co-op programs and re-energizing those co-op programs to be more than just simply an internship, but really a true partnership and engagement with universities and industry?
Mm-hmm. Internships are absolutely critical. We see it as, quite frankly, when I have an intern and I can convert an intern, it makes my entire organization, my HR organization, very happy, because when you look at, we did an internal analysis of our interns and then subsequent hires and college hires. And because we've been ramping up our college hiring each year since 2013. And what we found was that one of the greatest predictors of a quality hire, and let me tell you, we defined it arbitrarily, so I'm going to tell you what our qualities were. They stayed. That's really important, retention. They performed well. And hopefully they were even promoted within that 3-year period of time. So it was a logical kind of, and when we looked at all the attributes, the biggest predictor of a quote-unquote quality hire in that definition was whether or not they had an internship. So we've taken our internships up from 1,000 in 2013. We hired 1,000 that year. We hired 2,286 this year, not that I'm counting. It's really an important source of talent. I like internships. I like co-ops for all the points that the panelists made. Hands-on learning is what these kids need. It is great what they get in the universities and the project-based work that a lot of the universities are doing. We support that with many of our university partners as well. But there's nothing like coming in and trying on a position in the company. And then if that one doesn't fit, the next internship would logically be somewhere else because it makes sense in terms of retention with the company and, quite frankly, lower recruitment costs overall. The other challenge that an aerospace and defense company has right now is clearances. You may have heard that the clearance process is a little backlogged. And it's really important that because we hire about between 60 and 70% of the people either have clearances or they need to be clearable. And so we can get those interns into the clearance process once they've committed to their return and a conversion to a regular employee. Our target is 90% conversion of our interns. We converted 95 last year. It's really important to us. We like them to get the experience and adjust that sometimes that they need. Sometimes they just need to learn something about business acumen. Maybe it might be communication skills. We really want to work side by side and help them. So interns and co-op programs, recently the executive order that was out on apprenticeships, we're hugely supportive of anything that will get these kids the hands-on experience so they will be successful from day one and stay with the company.
Just to sort of, add on to that, I mean, not only just sort of an internship or a co-op where you're doing a semester at a time, we've got a great collaboration with Delta Airlines. If you go to Atlanta, you see all their hangars, they're rebuilding aircraft, they're rebuilding engines. I have students over there all over that, working there. And they may go there just on a Friday afternoon and so forth, And again, the advantage of these kids down there. So they were having problems with data entry. I'm rebuilding this turbine blade, and I have just one of these, and here's the big long serial number and so forth. And so the student said, well, why don't you just print out a QR code for that? And then Delta said, okay, yeah, and then we can buy a bunch of barcode readers. And students are like, no, in one of our little freshman classes, we wrote apps. Here's your barcode reader. In effect, you have it on the Delta app already, right? And that was it. And all of a sudden, everybody with their barcode reader, they're off, reading it and so forth, and data entry errors that went to pretty much zero. And the students just love it. And by the way, the Delta engineers and technicians are over in our facilities as well, trying out some of the latest and greatest machines, right, built here in America. And they're like, hey, we really like this. Let's order, 10 or 20 of these things. So there's a lot of good synergy there. So it doesn't necessarily even have to be, an entire semester experience. A lot of the local industries I noticed, right, Denise, you're talking about some of your local, colleges and so forth. It's really nice to engage there, and they're around. Lane, maybe you want to.
Yeah, I mean, I can comment directly as we're creating our curriculum. We put a 6-month internship at the end of our curriculum for every student. So 100% of our students go out on an internship, and we put it at the end on purpose. They have their technical skills, they have got their toolbox, and now they're going out and they're learning some more of these soft skills, teamwork, not having enough information to solve the problem. And for a large majority of them, they just do their internship and then they start working, and there's this little graduation thing on the way, but it's basically a full-time job for them.
Lynn, can I ask you, how does that work out for them financially?
Very nicely. So yeah, I mean, a lot of times the internship, they'll hire them as a full-time employee 6 months before they get their degree, and they go through.
Yes, please.
I would just really quickly, we actually have a vastly expanding program at WPI, which I won't really talk about, but to me, you hit on something that I think is important. Things like co-ops and internships to a lesser extent, but co-ops especially, can really be enablers for families who are struggling with the cost of higher education. Not only do they provide fantastic experience for students, but imagine instead of paying tuition for a semester, you're earning $25,000. That's a huge financial swinger for families. More than half of our students today come in with enough AP credit to be sophomores by December of their freshman year. So they have time in the program to be able to either graduate early or, even better, go out and get that real world experience and get paid for it as part of their time as a student. So there is a lot of opportunity for creative flexibility that really is enabling for families these days.
Excellent. Good. And we have a question back there. While Samantha's going back there, I should also point out, in engineering and sciences in graduate school, typically those students are supported by research assistantships solving problems for either industry or for government or for somebody, right? So not only undergraduate, right, but the opportunity to go to advanced degrees, also supported there, just financially. Yes, sir.
Yes, my name is Dr. James Turner. I'm with the Dana Alexander Payne Community Development Corporation. Change the Equation put out one of their vital signs reports in 2015 about engineering. And they found that about 5% of engineers are African Americans. That was down a bit. About 5% are Hispanics. That was up a bit. but still the numbers are too low.
Horrible.
And so since students, as I guess studies have shown that students begin forming notions about what they want to do as a career in middle school, before middle school, and also they start to make curriculum choices that can really disqualify. I mean, if they don't get in the right math track or science track, they won't be able to be credible applicants as seniors in high school to go to college as a STEM major. So are there some lessons learned that you can share with us, not only to attract more students at an earlier age, before middle school, but also to retain them in the STEM pipeline?
I can make some comment there. We have an annual event for the Gateway to Technology, which is the 7th grade group that come in, and we teach them about manufacturing. We teach them about automotive engineering. We host a big competition event for the vehicles that they've been developing. We worked with them on their own curriculum. And you're exactly right. 6th, 7th, 8th grade, people are making decisions right there about what they're going to do for the rest of their life. I can handle 80 students a year. We need a program that can really expand that out. And again, best practices for if it's a vehicle competition, if it's a manufacturing design competition, you got to get them right at that critical age when they're not kids anymore, but they're not at the point where they've made decisions about what they want to do. We get half male, half female come walking in the door. If I were to do that in high school, we would get 3 girls, that might be interested in it. And so there are people that are making decisions about that, and we got to get them right at that critical age. And a large programmatic way of doing that is what's needed.
Yeah, I totally agree. I mean, the pipeline programs are really, really critical. And I think most all colleges and universities these days are bringing more and more students onto their campuses. In the summer, we have over 2,000 K-12 students, a lot of them in specifically targeted camps for women and underrepresented minority students. And the other thing that we did, we were the first technological university to go test optional for admissions. So you don't have to take the SAT to come to WPI. So there are also shown to be biases in a lot of these standardized tests. So it doesn't necessarily help with the opting out of physics, but it can help with some of those things. And so just to kind of start to remove those barriers, you can tell a different story. If you were a first kid who built robots and just loves it, come tell us that story. You don't have to take the SAT to come to a place like WPI. So,
and I think the manufacturing, there's a lot of programs that we're running through the Manufacturing USA Institutes in helping build the maker-minded mentality around, I mean, I know we've talked a lot about engineering today, but manufacturing is similar, but sometimes different, right? Sometimes you don't have to be an engineer to be a manufacturer, and it's not mutually exclusive or inclusive. So the Manufacturing USA Institutes were all founded in specific geographic regions where there was at one point in time a very strong manufacturing backbone. A lot of those regions and areas of the country are economically depressed. And so revitalizing the manufacturing capability in the advanced manufacturing space allows for the opportunity for programs in the K through 12 space to help reinvigorate that mindset of the maker-minded and redefine what manufacturing really is. A lot of what we do is the rebranding. And we're working with a lot of schools that have been successful in looking at project-based learning and also changing the cultural mindset. There is a problem in this country that we have all created where the idea is that you must get a 4-year degree in order to be employable. And that is false. So what are we doing about it? We're going into these schools where you have champions who are having the conversations with the parents and saying, hey, John is a really smart kid, but you know how he learns? He learns with his hands. His math skills aren't great, but he has an incredible design aptitude. Have you thought about teaching him? We've got him on a 3D printer, and he's one of our best students. So going to a technical college might be the best fit for him. And providing support to those champions, those teachers, those principals that are having the conversation with the parents and changing their mentality about the 4-year track. Because it is not for everyone. And frankly, we don't need a bunch of college graduates sleeping on their parents' couches. It's not economically viable for any of us. So we are trying to change the dialogue. The other program that's been quite successful is the Military Child Program that's run out of our STEM office. So that's funding that was specifically geared originally towards providing STEM education to schools that are on bases, but because of BRAC, a lot of the bases have closed. So the base schools, and a lot of the base schools have closed because of funding and resourcing. So the Military Child Program still exists, and what it looks at is where those schools where there are at least 100 students of military service members, and or they are a certain percentage of the population, and those schools are eligible for the Military Child STEM funding program. And that has been, I'm going to get the numbers wrong, estimated there's around 200 plus-ish schools, and the goal is to have there will be over 800 schools impacted because that's the number of schools, middle and high schools, that qualify under that requirement of the number of service members' children. So it's a cultural problem, but it's also it's an economic growth problem, and we're trying to deal with it in different ways.
Good. Stephen, really quickly, and then I want to squeeze in one more question back there, and then I think we're going to have to call it because we're going to run out of time.
I would just also call your attention to an ITF study called The Demography of American Innovation, which surveyed 7,000 U.S. patent holders since 2000 and found that 12% are African American, 8% are women. So that report included a number of recommendations for how to solve that challenge. And I think a lot of it goes back to, in particular, hands-on, project-based, team-based learning at an early age that encourages wonder in students. And I think a particular point of this manufacturing engineering education program is that successful applicants are going to provide an analysis of industry demand and population skills needs in their own region, and asking for a specific strategy for how federal resources can help modernize curriculum, particularly in local high schools and universities, to address these needs.
Excellent. All right. Last question. We'll knock it off quickly.
Hi,
Get everybody
good
out.
afternoon. Nate Hartman, Purdue University. I would just echo everything that a number of folks have already said up there. But so the question I have is, we've talked a lot this afternoon about the traditional pipeline of how we get students into companies and the like. But what about, it was just talked about 6th, 7th, 8th grade, people are making decisions. I have an 8th grader that I'm not sure how he gets through the day with his shoes tied. And so how can we expect them to, make decisions about the rest of their life, even with the proper guidance and the like that we may give them as parents? And so one of the things I think we also need to think about is how do we address the non-traditional pipeline, and whether it be by way of someone who may have had hard luck early in life, they didn't take the traditional academic route. Maybe it's somebody who went into military service or civil service right out of high school, and yet all of a sudden now they've discovered they want to do something that is technical related, and they want to go into an engineering or manufacturing career, but they have all this life experience that they can benefit from as well. So how do we help those people?
So I can speak to a couple programs specifically around veterans that we're running. So we have Operation Next, which is a program at LIFT, which is our Lightweight Metals Institute, and it's at Fort Campbell. The pilot program is there. The idea is that you would be able to provide online self-paced training as well as lab learning with the local community colleges in NIMS certifications. So those are industry accepted credentials in machining, and you would provide the opportunity for the veteran to take the courses, and a lot of it is geared towards these folks, just like you were mentioning, who may have enlisted, so they've gone into service and they've served for 10, 15, 20 years. They now are supporting a family, and they are getting out of service, and they need to have a viable career, but they don't have a degree. So how do we help them? So the program is geared towards utilizing their real-world experience, because they come at it with a lot of real-world experience, hands-on and otherwise, and taking that, they take a self-assessment, which then provides them with their particular curriculum based on the experience that they come to the program with the goal of them having the certification upon date of separation. So there is no time lapse between the time that they take off the uniform and the time they become a civilian. We have a problem in this country where we haven't provided a very robust ecosystem, and we have a lot of veterans who go through a long-term unemployment after they serve. And as the daughter and the granddaughter and the sister of veterans, that pisses me off. So we're trying to change that. The other program that we have is a 3D Vets program through America Makes, which is actually open for any veteran. You can have separated from service at any point in time. One of the best graduates he's in his 50s. He was in the first program. He's been out of service for quite some time, and he wanted to change his life. He wanted to do something different, and he wanted to get into a new technology area. And so it takes you through a boot camp around 3D printing. The first pilot was done in San Antonio or El Paso. I always get them confused. And the second pilot was actually done with GE, where they gave a problem-based learning curriculum that GE had, and they put the folks through the pilot. It's happening right now. The 2 pilots are going on. The second 2 are happening this month. And the idea is that at the end of it, you would have a full comprehensive understanding of additive manufacturing in the aerospace and in GE's essentially industry. The first pilot, they had an 86% graduation rate. They had, an 100% graduation rate, and as of 2 weeks ago, an 86% employed and or provided funding for a new startup. So we are trying to recognize that and to build core curriculum, which we have a competency model that we've built in advanced manufacturing technologies that gives credit where credit is due for that real world experience.
So I think just very briefly, so that is a great couple of examples of where I think the industry is headed, which is thinking really different about the credential in education. So there are always going to be those 18 to 21-year-olds that want that traditional credential, and I think that's great, and I would argue we need more, not fewer of them in this country. But there are lots of people who have lots of different pathways to get to the education that they need now. And so we need this idea of more flexible, personalized, and stackable credentials to get those folks to where they need to be. The importance of having government engaged in helping us think through how best to do this is there are a lot of predators out there who will take advantage of people in need, who will charge them lots of money for a short-term program that will not get them where they need to be. And so this is a dangerous moment. It's a moment of a ton of opportunity and a ton of innovation. It's also a dangerous moment. And the last thing we want is these most vulnerable people, the people whose brains and efforts that we need the most to move our country forward, to be taken down the wrong path. So again, huge opportunity to collaborate between government and education.
I think just one other point.
Our last word. Go ahead, Denise.
Yep. I think that it's incumbent upon the four-year universities to also get very creative in helping these potential students to pursue their 2-year and 4-year education by partnering with the community colleges. We think that that is critical. Affordability is a big issue. You cannot believe the number of people that we hire with huge debt, and they want us to solve it for them, and that's not a value proposition for the shareholders. So we have to help them get an affordable education, and part of it is by the creativity that the four-year institutions can use and using all the other government programs, the Pell Grants, the Perkins, and we really want to make sure that we do a partnership, and we're looking at this right now in Florida, is a partnership with a community college for the first 2 years and then the degree through the four-year institution. It makes it more affordable. So we think it's a partnership with all of us, and we need the help of the four-year institutions to get creative and get these populations into these programs so that they can be successful too.
Great. Well, thank you very much. I think that's all we have time for on the Q&A. On behalf of ASME, I would like to thank you all again for joining us today, and we look forward to working with actually everybody, a lot of people here in the audience, on supporting the domestic advanced manufacturing programs to ensure a bright future for our national defense and economy. I've also been told that this briefing has been recorded and will be posted on the Manufacturing Caucus website for your reference. So I would just like to give you a, is that correct? Yay. Okay, I got the thumbs up there. Great. So I would like to just give you a closing thought from a 20th century philosopher by the name of Eric Hoffer. And that is, and he made the statement, I think it's very true today, maybe even more true today in the 21st century. Learners will inherit the world, while the learned will find themselves beautifully equipped to deal with a world that no longer exists. So just keep that in mind. And again, thank you very much for your attendance here today, and let's thank the panel.